Hey everybody, it's Phoenix 1015 coming at you guys for part 20 of my pre-algebra tutorial. In the last part, we covered chapter 4 of what is my, so to speak, curriculum for this online course, tutorial rather. I went over properties of real numbers, and real numbers are basically defined as numbers that we have a real value for. More on that when we get into algebra. This is pre-algebra, don't worry about that. Now, I just wanted to talk to you guys a little bit about what really algebra is in my perspective. In my eyes, algebra is, so to speak, more or less just simply the study of using properties and facts about numbers, real numbers, known numbers, to figure out facts about unknown numbers. For example, the only way we've really figured out, like mathematicians way back when, that x plus 4 is going to equal to 7, and figure out that x is going to wind up being equal to 3, is because we know for a fact that 3 plus 4 equals 7. So something plus 4 is going to have to equal 7. Well, that's going to be 3. And then from that, mathematicians then decided, how can we figure it out? Hey, why don't we just subtract 4? You know, they did stuff like that. But it all began really because they knew the properties about real numbers. So this is where we get into chapter 5, which is going to be based on monomials. Now that sounds like a really big, complicated word. You're going to get so familiar with this over the course of the next, let's see here, the rest of algebra, that you'll be able to dish out what a monomial is right away. No way. It's going to be bad knowledge for you guys. So, in this part, I'm going to work on adding monomials. But first things first, I'm going to give you an example of a monomial. There you go. I'm going to give you examples of monomials. See what you notice about it. Sorry about that background noise if you guys hear it. I don't know if you can hear it or not. But, anyways, these are examples of monomials. And I could even do this. And we'll make that really complex. And that's, actually, I will change the decimal point. That is still a monomial. So can you think about what a monomial could really stand for? A monomial really is a bunch of terms, or variables and constants and everything, being multiplied together. So monomials can range from being as simple like that to as complex as this, even so far as to have a division, because as you learned, addition and subtraction are essentially the same thing. You learn pretty soonish that division and multiplication are essentially the same thing. So this is also a monomial. What is not a monomial, however, is when you start adding or subtracting things. This actually is a polynomial or binomial, but we like to call them polynomials. So we have monomials, which are basically the ones. We have the binomials, if you can tell, these are all prefixes. No, okay, whatever. And then polynomials, which is 3 or more. And for chapter 5, however, we're just going to be dealing with simple monomials, forming monomials, and a little bit of binomials, you know, just differentiating. Today's topic is going to be adding monomials. And you might think to me, you might ask, how can you add monomials? I thought that they were entirely different concepts. Well, that's when we go into the concept of like terms. I might have actually touched on like terms, but now is the real time we're going to get down to the bulk of it and really learn what a like term is. A like term could easily be defined as two monomials that could be added together. And the only way to really identify a like term is to do it yourself. Now, let's say we have this expression. Remember what I told you, expressions don't have an equal sign. Let's say we had this expression right here. We're going to be dealing with a lot of expressions because this is all theoretical based. This is all basically going to be expressions. So let's say we had 6x plus 2x. And I gave you these instructions simply to simplify. And simplify means to put in best form. Best form means most simplified form. So simplifying. How are we really do this? Well, we could always add these two together. But in order to do this, we'd have to make sure that two numbers are like terms. Now, a like term is either a constant or a set of variables. As long as the variables match up, you can combine the coefficients. that is a very broad term. Let me give you some terminology real quickly. A coefficient, I might have gone over this. A coefficient is something that latches onto the x. So 6 is a coefficient. What do you think the coefficient would be? It'd be the constant. It'd be 49. So you'd add the coefficients when you're working with working with like terms. And all you do to determine whether something's a like term is you analyze the variables. And this also goes into a quick note, side note. These would be like terms because there is no variable. So the lack of none, you just combine them. So we look at the variables to determine whether two monomials are like terms. And as we can see, we have x to the first power and x to the first power right here. They both are the same thing, so we're going to get 8x. And I'm assuming you know what simple exponents are, like 3 to the second power. You know, the second power is a 2, 3 is the base, 2 is the exponent. I'm assuming you know that. If you don't, however, chapter part 30, way later, you know, just touches that up on a little bit. If not, though, you might want to watch my basic math tutorials coming up. They will also be really good in helping you dissect what I'm talking about. So, yeah, 6x plus 2x equals 8x. Kind of makes sense. Let's try to see if we're right. 6x plus 2x equals 8x. We're actually going to make a somewhat of an equation. Let's say x equals 2. So we get 6 times 2, which is 12, plus 2 times 2, which is 4, equals 8 times 2, which is 16. So then we check it, and bam, 16 equals 16. So it looks like you were right. Let's check. Let's try another one. 6x plus 2y now. Now, this is where we have to start analyzing our variables, like I said, and see if these are like terms. Well, we have an x right here, but we don't have an x right here, so they can't be combined. So if the instructions were simplify, all you could really do is just rewrite the answer, 6x plus 2y. That is in simplest form. You can't simplify it anymore. You don't know the values of x, you don't know the values of y. You really can't do anything else with that. So then our answer simplifies out to be 6x plus 2y. Let's try another one. Let's say we had 6x squared plus 2x squared. Could we, and the directions are again to simplify. Write that down. What we're going to want to do is ensure that our variables are the same, x and x squared and x squared. Okay, we're good. So we're just going to simplify it and it becomes 8x squared. Let's go into a little one that requires us a little bit more of actual thinking work. Let's say we had this long, complicated expression, 6x to the fourth y third plus 4x to the third y squared z. Now, remember my rules for determining whether something's like term. You got to check all the variables to make sure they're the same. And you also want to make sure, another note, variables must be the same number and exponent. Oh, same variable and same power or value or, you know, I don't know. There's 20 million ways of saying something about a variable. Degree. That's the word I was looking for. So let's see here. We have an x to the fourth. Do we have an x here? We have an x to the third. We automatically figure out that we can't add these. So that it'd be in simplest form if we just rewrote it. Let's try another one. 9x cubed y cubed plus 12x cubed y cubed. All right, let's check this out. X cubed, y cubed, y cubed. All right, so we have the same amount of variables, and then we wind up multiplying, adding together. 12 plus 9, 21, x cubed, y cubed. All right, so that's basically what adding monomials is all about. Let's try subtracting them too. Actually, let's just try this one right here. I wrote out a bunch of them for this tutorial because I just wanted to not be totally horrendously out of it. Now, first things first, we want to make this a little bit easier for ourselves. So I'm going to go ahead and use the commutative property of addition. If you don't recall what that is, I'm going to make this equal to positive plus negative 2x, and that makes this entire thing a commutative property problem, which means it could work. And then I'm going to rearrange these variables around to make it 6x plus 3x plus negative 2x. Basically, I move the 3x. I'm going to get this in red or something. I basically move the 3x in between those two. So it becomes 3x plus 3x plus negative 2x plus 3y, and then I'm going to just rewrite this as subtraction, so it becomes 6x plus 3x minus 2x plus 3y. And now we just want to make sure, we just want to identify all the like terms. So let's check all the like terms that are x. This is x and this is x. So we're going to multiply all these together. Do we have any y's? Well, this is a y, but we have no other y's. So the only three that can be added together are these three. What order we add them in? Well, remember, the associative property says it doesn't matter what order we add them in. I'm just going to go left to right. It really doesn't matter. 6 plus 3 is 9. 9 minus 2 is 7. Or 9 plus negative 2 is, that's how the associative property will work. 9 plus negative 2 would be negative 7x. So 9 plus negative 2 would be positive 7x. What am I talking about? So now we get 7x plus 3y was the answer. Stupid thingy. 7x plus 3y was the answer. Let's go with one more. Let's see another good one that I can give you guys. Ooh, this one's a take it out the door kind of problem. This one's pretty intensive. A lot of degrees. Plus 3x squared plus 4x plus 3x plus 7y plus y squared. Okay, this is a doozy. Now let's just analyze all our like terms, group them together. This will make the problem 10 times easier to solve. I'm looking for all my x squareds. This is an x squared. That's not an x squared. It's not an x squared. Not an x squared. Not an x squared. All right. Next like term groups. Like terms can be more than two variables, by the way, as you just saw. Wrong color. Nope. Ignore that. Nope. Green. Okay. X and x. All right. Do we have any other ones? Oh, that's that color. Y's and y squared. Alright, so we can going to find these two to get 5x squared. These two to get 7x plus 7x. Oh, wait a second. If you caught on, these two are not like terms because this is y, but this is y squared, and we can't add them. So our answer would have to be plus 7y plus y squared. Now, this will be the final answer. Let's just check to make sure that we can't do anything. We're not just messing things up or forgetting about things, and that we actually are confident that this is our final answer. Let's see here, 5x squared plus 7x plus 7y plus y squared. Can you point out any two pairs that are not like terms yet? You can't. All of the following monomials, see that term coming back again? These are all monomials. All these monomials form together to form the simplest polynomial possible. So I'm going to write simplest polynomial. Now, before we go today and end this part, I just want to ask you a simple question. Now, don't you feel powerful now that you can say words like polynomial? See you guys later.